Okay, your confidence interval. You're trying to estimate, get good estimates that the population mean is going to be in between specific values. And that's what we're trying to estimate. We're trying to estimate specific values for the population mean. And how we can do that is by using our z values that we talked about and calculate two values. We have our sample mean. Our sample mean, our z for the confidence interval. Now, you had a table with your notes, and today I'll give you an additional table that you'll be able to find from the additional table. But from your notes, you have three values that you can use for your confidence interval for a specific z value. We multiply that by the standard deviation divided by the square root of n. It is not a very complicated thing. We just have to remember how to calculate it. If we take a look at problem number, let's see here. Take a look at problem number 3 in the back. Yeah, 35 golfers showed the average score in a particular golf course was a 92. Not very good. The standard deviation was a sample of the sample is 5. We'll do a 99% confidence interval. We have our sample mean is a value of 92. Our standard deviation is a value of 5. We have a sample size of 35 golfers. We have a sample size of 35 golfers. If you have not done this, you should be doing the problem right now. Okay, we're doing a 99% confidence interval. Well, we have a sample mean of 92. We have a standard deviation of 5. We have a sample of 35. From our table, we can find a z for that confidence interval. Get a z for the confidence interval for a 99% confidence interval is what, Owen? Huh? No, the confidence interval. The z value for that confidence interval. 2.58. .58. So dealing with a 99% confidence interval, this is our z value. This is the value we're putting in for our z. So we have our mean, which is 92, minus 2.58 times the standard deviation of 5 divided by the square root of 35. And then we have the exact same thing, but we add the 2.58, standard deviation of 5, divided by the square root of 35. So we have two things that we have to calculate. And you can click and clack this straight into the calculator. You can go 92 minus 2.58 times 5 divided by the square root of 35 and hit enter. And then 92 plus 2.58 times 5 divided by the square root of 35 and hit enter. Kylie, what's the two values you come down to? 89.8, and what's the other one? 94.2. Good with those values? Okay, what you need to write when you complete this, you need to write a statement at the end. We are 99% confident the population mean is between 89.8 and 94.2. And you need to get the statement down at the end. That's part of the problem. And what we're saying, we're 99% confident, means we're pretty confident in that. Okay, given the data we have, we're going to shoot anywhere between those two scores. Now, part A, skipped over part A. What's the best point estimate for the mean? What's the best point estimate for the mean? No, we have to go back to what is the best point estimate. What is our best point estimate, Brooke? 92, the sample mean. The best point estimate is the sample mean. So whatever your sample mean is, that's your best point estimate. 92. Everything on here pretty much is redundant. It's doing the exact same process over and over again. You just change your z-value. Any other questions you have? Okay, we're going to go through new material today, tomorrow, Wednesday. Thursday is going to be a review day. Friday is going to be a quiz. Monday will be a review day next week. Tuesday next week will be a unit test over Chapter 5 and Chapter 6. So you need to keep up with the material here. When using the z-table and the z-scores for the confidence interval, we are guaranteeing that, once again, the sample size is greater than 30. That's what we want to make sure of, is the sample size is greater than 30. Well, what happens if the sample size is less than 30? We still want to get a good guesstimate in there. So what happens when the sample size is less than 30? We still want to approximate the population mean and with confidence. Well, what we utilize is a t-distribution. It is a t-distribution. We utilize a t-distribution when the sample size is less than 30. The table I'm handing you out will be the table that you will utilize for all your problems for the rest of the semester. Once again, my goal in this class is to have our final before we go on Christmas break. We have 2 more chapters to cover after Thanksgiving break. Usually takes about a week and a half to do that, and that gives us another week and a half to prepare for the final. We come back from Christmas break, we will have a statistics project to do, a survey project. But when we're dealing with a sample size that's less than 30, we use what is called the t-distribution. The nice thing about the t-distribution, I told you did not have to memorize those values for a z for the confidence interval. And the reason why is on the t-table that I give you here today, you'll be able to find those z values. Once again, we'll have to have some fill-ins on the next quiz. Okay, we still maintain characteristics of a T or Z distribution. We maintain it's still a bell-shaped curve. We're symmetric about the mean. Okay, all these characteristics are characteristics of a Z distribution. And the T distribution will maintain these same things. Bell-shaped curve. Symmetric about the mean. Mean, median, mode equals 0, located at the center of the distribution. Curve never touches the x-axis, the horizontal axis. You're asymptotic there. Those things will maintain the same with the T distribution. Bell-shaped curve, symmetric about the mean. Mean, median, mode equals 0, located at the center of the distribution. Curve never touches the x-axis. These are all things that will be the same to what we've been dealing with. What's unique to the T distribution? And once again, you'll have to provide these. The variance is going to be greater than 1. Where the Z distribution, with the normalized Z distribution, our variance was equal to 1, the standard deviation was equal to 1. When you talk about a T distribution, the variance is going to be greater than 1. The T distribution is a family of bell-shaped curves based on the degree of freedom, which is based on the sample size. The T distribution is a family of bell-shaped curves based on the degree of freedom, which is based on the sample size. As the sample size increases, the T distribution approaches a standard normal distribution. Once again, law of large numbers. Law of large numbers. As the sample size gets greater, you will approach a normal distribution. Law of large numbers. This is what we've been dealing with up till now, normal bell-shaped curve. As the sample size decreases, what starts to happen here is the hump on the side of the camel's back starts to get higher and higher and higher. So as N gets smaller, the hump on the side of the camel's back gets higher. As N gets bigger, it starts to come back to what is the normal distribution, a normal bell-shaped curve. Basically what happens is if you take your two hands and you sort of squish both sides of the bell-shaped curve, you squish them together. When you squish them together, it starts to pop the hill up a little bit higher. That's why this is a family of bell-shaped curves. This area still equals 1 now. The area still equals 1. So once again, you start squishing that bell-shaped curve together, you still have an area of 1. When you squish, okay, the hump on the side of the camel's back starts getting higher. Now probably comes the most difficult computation that we will do statistically wise in this class. How we calculate this degree of freedom is based on the sample size. How we calculate the degree of freedom. Get ready. You take sample size n minus 1. Whew. Might have to click that one through the calculator. So if your sample size is 20, the degree of freedom is 20 minus 1, 19. How we calculate the boundary values. Is the exact same way, except for now we have a t value for the confidence interval. Yes. Is that in my group first period? This is the left, right? Yep. Yep. So we replace the z and put the t in there. Now let's take a look at your table here. The t table I handed out to you. The t table I handed out to you here. On the t-table, on the left-hand side, you have a d dot f, degree of freedom. Along the top, you have confidence intervals that you're dealing with. A 50%, an 80%, a 90%, 95%, 98%, 99% confidence interval. So you have confidence intervals along the top. You go to that confidence interval column and you take it down to the appropriate degree of freedom. and that's your t-value. Now, what I said in regards to not having to memorize the z-values, if you go down to the very bottom on the left-hand side, what it has there, it has the z-value. And I can go across and find my z-value for that confidence interval. Now it goes 3 decimal places rather than 2. And they have little stars there, or letters that you can use those values. You can use either of the values. A recent study of 25 students showed that they spent an average of $18.53 for gasoline per week. Hey, we're getting back down to that now. Sort of nice. The standard deviation of the sample is, should be $3. Should be a decimal point in there. $3. Find the 90% confidence interval for the true mean. So we have n is 25. We have an x bar, sample mean, $18.53. We have a sample standard deviation of $3. We want to do a 90% confidence interval. Now, when to use a t, when to use a z? Well, it really doesn't matter. What I would suggest you do is do your degree of freedom. Your sample size is 25, which means my degree of freedom max would be what? How do I calculate the degree of freedom? N-1. So what do we have? 24. That is correct. I didn't even hear any clickety-clacking. That was good. So my degree of freedom is 24, so I'm going to go down my left-hand column to 24. I'm going to go over to my confidence interval of 90%. So I'm going into 90% column, going down to the 24. Finding a table value. All right, what do you get? %90% column down to a CI, or a degree of freedom of 24. 1.711. Anybody not be able to find that? So we have to calculate our confidence interval. So we have x bar minus a t for the confidence interval, or z, doesn't matter. Standard deviation, square root of n, mu, and then the same thing but a plus. So go ahead and plug in your values, check your answer with somebody around you, and write a statement. Check your answer with somebody around you. Now, when you divide by square root of n, it's square root of 25, not the square root of the degree of freedom. Vivi, what two values did you come up with?
17.5 and 19.56.
$17.50 and $19.56. Good with that? Then we write our statement. We are 90% confident the population mean is between 1750 and 1956 for students spending on gasoline per week. If you want to be more confident, you're going to have a bigger confidence interval. Just because this t value or the z value gets bigger. So if you want to be more confident, you're going to have a wider interval. To find a confidence interval, sample size must be large enough. Once again, we try to use over 30. But if not, for an error, for a specific error, we can find what sample size we need to be specific to a specific error that we are dealing with. And how we calculate this minimum sample size is n, z standard deviation divided by error. And once again, this is x bar plus or minus this error. This error is z for the confidence interval, standard deviation, divided by square root of n. I should throw a squared in there, my bad. That should be a square with a minimum size. And how this is derived basically is multiplying both sides by square root of n, square root of n. And then dividing by e. So we have square root of n is equal to z, standard deviation divided by our error. And then we square both sides. So if you're willing to accept a specific error, if you're willing to accept a specific error for a specific confidence interval, to find what your sample size has to be to get to that error, you can calculate how many people do I need to survey? Or how many data values do I need to get that specific error? Take a look at problem 3 on the worksheet here. 1 and 2 are very similar to what we've been dealing with. Problem number 3. Problem number 3. You have a sample of 17 states for cigarette taxes in cents. Okay, what is a cigarette tax in cents? I want to find a 95% confidence interval for the population mean, which is all the states. This is just 17 of the states. I don't give you the mean or the standard deviation. But what you're able to do now, if you go to your calculator, hit your stat button. The first thing that you have there is an edit. Hit enter. What it gives you is a table. Okay, now if you have data values that are there, and you want to clear those data values out, hit second and quit, which is your mode button right beside it. Along the right hand side, hit your second and your plus button. The second and your plus button. Your addition problem. Your addition. Okay? Option number 4 says clear all lists. So hit 4, hit enter, hit enter. It'll clear all your data values out of there. Now go to do your stat button again. Go to edit. Now you're clear. Your list should be cleared. List 1 should be cleared. Type in your data values: 112, 120, 98, 17, or 98, 55, 71, 35, 99, 124, 64, 150, 150, 55, 100, 132, 20, 70, and 93. Type them in. Little KYC exercise here today. Okay, now you can hit second in mode, which is quit. Get yourself out of that. Go to your stat button again. Option 2. Option 2 is to hit your right button, go over to calculate. There we go. What we want to do is calculate one variable statistics, which is the first option. Hit enter. If you have to, go down to calculate off of that too. Some of the newer calculators make you jump through another hoop. Some of the basic ones don't. What it gives you is all your statistics. What you want to pull off of that one, what is your X bar and what is your sample standard deviation? You want to find your X bar and your standard deviation and write them down. So what you just generated with a list of data is you generated a mean and a standard deviation. Now you can go, okay, I have a sample size of 17. Your degree of freedom. I'm asking you for a 95% confidence interval. So So you look at your degree of freedom, you look at your 95% confidence interval, find your t-value from your table. So you go to 95% along the top, you drop down to degree of freedom of not 17. But our degree of freedom is one less than that, and calculate your value, or determine your value. It's primarily what you've been doing, what you did for today. The difference is you need to find a t-value now. That's the only difference. Okay, the rest of the time is yours.